Today we're going to be working on polynomial functions, okay? We're going to look at this graph that's in your notes right here. We're going to talk about different things within the graph. Right now it tells you two things. It says n is odd and n is positive. Now that doesn't make a whole lot of sense until you look at this right up here. So right now, if you look at this, the f of x equals a subset n, x to the power of n. But just to make it a little bit easier, let's just call this number in front of the x a, and then let's just call the power n, just to make it a little bit easier. What it's saying in this particular graph, the way it looks, it's telling us, without telling us the exact number, it's saying the exponent, the power up here, all right, is going to be an odd number. And it's also saying that this a value right here is going to be a positive. So what I want you to do is I want you to label a as positive. So right, not positive, additive. Not last in here. Try again. Positive, there we go. A is positive, and this number right here is going to be odd. Now, I'm not sure exactly what type of function this is, but I definitely know it's going to be an odd function, and it's not going to be a linear function, okay? So what's the next function after a linear function that's odd? We have y equals x to the first, we have y equals x squared, and then we have y equals x cubed. What I'm going to say is, you know what, this is most likely going to be a cubic function. It's definitely not linear, it's definitely not quadratic. So we're going to label this right here, guys. This is an example of a cubic function. So what I want us to do right now is we're going to create this something. We're going to create a cubic function that looks similar to this one. So what I want us to do right now is I want you guys to look at these points right here. What do we call these points where it crosses the x-axis? Those are zeros. So right now, in this graph, we have three real zeros. We have three real zeros. Now let's just estimate. What would be a good number to put here if we were just to estimate? What do we think that zero would be? Negative. You want to say negative 3? Okay, we'll say negative 3, 0. That's fine. Right here, this is pretty easy. What's that zero going to be? 0, 0, right? And what about this one? Put 2, 0? Okay, 2, 0. All right. Now we're actually going to build a function that crosses here, here, and right there. So what I want you to do, in this section of your notes, I want you guys to write this. F of x equals. And if I were to create a function that would include all three zeros, I would simply say x plus 3, x, and x minus a 2. Now I'm going to highlight each of these, all right? If I have a negative 3, 0, then my factor is going to be x plus 3. If I'm at 0, 0, then my factor is just going to be x. If I'm at a 2, 0, then my factor is going to be an x minus 2. All right, so these right here, this polynomial function is broken down into all of its factors. What number plus 3 equals 0? Negative 3. 0, 0. What number minus 2 gets me to 0? Positive 2. Now, typically, you won't see an answer that looks like this. Usually, you'll see x up front. You might see x plus 3 next. You might see x minus 2. But usually, you don't see functions where they're all broken into the factors. All right? We know this is a cubic function. All right? So right now, what I want us to do, if I FOILed that out, what would be my product between an x plus 3 and an x minus 2? It's going to be x squared. What's 3 minus a 2? 3 minus a 2 is going to be just 1x. And what's 3 times a negative 2? Negative 6. So if you wanted to FOIL it out, you could. But what's the fast way of doing it? Take these numbers right here, add them together, and that gets you your middle coefficient. So if that's confusing, you can also put a 1 right there if you wanted to, but you don't have to. And then you take these two numbers and multiply them together to equal the last constant at the end. Now, if you distribute it in x throughout the entire equation, what would f of x end up equaling if I distribute an x to every single term? Good. So, everybody, I'm just letting you know, in a problem, if you were given a problem to graph, it's most likely to be in this form. Okay, it's most likely to look like that. So what did we do? We took the what? We took the factors and built it into a polynomial function. So what I want you to do right now, take this right here and type it carefully into your graphing calculator. Take y equals, type in x to the third. Was it plus x squared? Plus x squared and then minus 6x. Type it in, hit graph. I need to zoom out a little bit. So I'm going to hit zoom, and I'm going to go to zoom standard 6. There we go. Take a look at that. Now, this is not the exact picture of this. Okay? But, you guys see how it's relatively close to our graph? We have 2 points at which the graph turns. These are called turning points in the graph. So if I ask you for a turning point in the graph, this is what I'm asking for. So basically, what are your turning points in the graph? If I wanted to be more specific. Right here, this is called a what? Relative maximum. So this is a relative maximum. And down here, this would be a relative minimum. Very good. So just remember, your turning points are either going to be a relative maximum, it could be a relative minimum, it could be an absolute maximum. What would an absolute maximum look like? It would be a graph where everything is what? Opening down. That would be a absolute maximum. What would be an absolute minimum? If your graph was opening up. This would be an absolute minimum. That's the absolute lowest point. Okay? Well, right now we have 2 turning points. Okay? We have 1, 2, 3 real zeros. Now let's talk about the end behavior. Where is this graph going towards on the right? It's going up towards positive infinity. And where's the graph ending up? Negative infinity. That's your end behavior. Okay? Now, we called this graph a what? We called it a cubic function. A cubic function, at most, everybody, at most, will have 2 turning points. Okay? So if it's a cubic function, which is x cubed, at most it's going to have 2 turning points. Now we could build a cubic function with no turning points. Okay. If I just said x cubed. By the way, this right here, is this going from down to up, or is it just basically increasing no matter what? It's increasing. A turning point is where it goes from increasing to decreasing, or from decreasing to increasing. This one, does this ever really stop increasing? Okay? It goes to right here at 0, right? But once it hits 0, is it still going up? If we zoomed in right here, you'd still technically increasing all the way up to what? From here to 0, and then from 0 up. So basically, the only place it's not increasing is at 0. That's the only place that it's not increasing. But it's not really turning. What do we call a point like this? That's not an absolute maximum or minimum, right? It's a point of inflection. Where the graph turns, right? It kind of changes shape, but it doesn't go from increasing to decreasing. All right, let's clear this one out. so here we have this graph right here. We've labeled all of our points. Now, right now, our a value is positive in our function. Okay? So right now, if we look at our function right now, we see it go up like this. Our a value is positive. Here's what I want you to do. Go to y equals. And I want you to do second, delete, and you're going to insert a parentheses. And I want you to go to the left, right here, where it's right there on the parentheses, hit second, delete one more time, and I want you to insert a negative. And then go all the way to the right, and I want you to close the parentheses. So what I've done is I've inserted a negative. Now I'm making my a value from positive to a negative. Look what happens to your graph. I went from this to this. Have the zeros changed at all? Let's check. Ready? Right here. Here's a 0. 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 Now all I want you to do is just focus on the red dots. Do the red dots change? They stay the same. So what's the only thing that happens in the graph? Now, what's happened? Has the end behavior changed? The end behavior has changed. Here, what's my a value? My a value is a negative. Here, my a value is a what? Positive. So in your notes, you see your graph in your notes, right? You have one of these, and you got one of these. All right? So what I want you guys to understand is what's happening to the end behavior between when a is a negative and when a is a positive. That's what you need to look at. So let's go ahead and go down to the very first problem. We're going to work through the very first problem. Okay? So right now, we're going to zoom out just a little bit so we can get all of our answers right here on the page. If you would, please, put a little dot right here, right here, right here, right there, and right there. Kind of hard to see, but how many real zeros does this graph have? Yeah. So there are actually 5 real zeros. Well, right now, at this one, we're just trying to label the real zeros. Okay? So right now, I just want everybody to see this. That actually lets us know, right now, is this going to be an odd or even degree polynomial function? It's going to be odd. Okay? So we're going to say this right here. The degree is odd. Okay? Mm-hmm. And we have how many? What's going to be our degree? We know it's at least a 5. Okay? It's at least a 5 because we see 5 real zeros right there. So we know it's at least a 5. Now it could be x to the 7th. Okay? It could be x to the 9th. It could be x to the 11th. But it has to be at least x to the 5th. Just like this last one over here. This one had to be at least x cubed. Because how many places did it cross? 3 times. Now, the leading coefficient. Do you guys think it's negative or positive for this one? What do you guys think? It's negative. So the leading coefficient you're going to write. We don't know what it actually is, but we do know it's going to be a negative. How many turning points do you see? I see a turning point right here. I see a turning point here. Turning point right here. And then way up here, I see another. Yeah. Nope, not 5. 4. I see 1, 2, 3, 4. I see 4 turning points. How many turning points did we see in the cubic function? How many? We saw 2. We saw 2 turning points in a cubic function. And we saw 4 turning points in a function that's raised to the power of 5. So let me explain something. This is how it works. Whatever degree you have, your turning points, at most will be one less than. Okay? Every single time, at most will be one less. Now, let's talk about our end behavior. Up here, it's going towards what? It's going towards positive infinity. Down here, it's going towards negative infinity. So how do we write that?
The limit of f of x reaches positive infinity.
So it reaches positive infinity
As x equals, or as x reaches negative.
so as x approaches negative infinity. So basically, this is what it means. As x is going which way? Which way? Going to the left. So as it's going to negative infinity, what's happening to all my y values? They're going higher and higher. But if all of my x values are going to positive infinity, what's happening to all of my y values? Going lower and lower. So see how I gave you guys two lines? So I want you guys to write, this is the left end behavior right here. Here's the left end behavior. Now we're going to write, let's do it down here so you guys can see it a little bit easier. I'm going to write the right end behavior. The limit of f of x equals negative infinity as x is going towards or approaching positive infinity. So there's your left end behavior and there's your right end behavior. Okay. All right, we're going to go to the next problem right here. Now, by the way, this one's a little bit trickier because technically how many real zeros do we have on number 2? Just 2. But you have 1, 2, 3. Oh, good. You're right, Austin. We have 3 turning points, but we only have 2 real zeros. So understand, this function, all right, the smallest degree that it could be is going to be a 4. It could be a 6, it could be an 8, it could be to the power of 10. But I'm telling you guys right now, this is, at the least, it's going to be a quartic function. This is going to be an even degree function. Why is it an even degree? Because look at the end behavior. You see how the end behavior is ending in the same direction. The last one was going up, 1 was going down. When 1 goes up and 1 goes down, or when 1 goes down and 1 goes up, that's always going to be what? Odd. Okay? Now, let me kind of go real quick. Look. Even. Even is what? Up and up or down and down. Odd is down and up or up and down. That will always be the case. So your even functions are always going to have what? The same end behavior on the left and the right side, no matter what. Okay? Just go back. Now, how was I able to figure out that this was going to be a quartic function at the least? Because here's what I want you to be able to do. Even though the x-axis is right here, what if I drew in the x-axis right there? What if I called that the x-axis? Then how many real zeros would I have? I would have 1, 2, 3, and 4. So what I want you guys to understand, if it's not super easy like the last one was easy. Where were all the zeros? Right there along the x-axis. If it's not there, what can you do? You can draw in your what? Draw in your own x-axis and imagine if I grab this function right here. I grab this function and I either pulled the x-axis down or I took the function and did what with it? Just grabbed it and moved it up. If I translated it up, how many real zeros could there be? 1, 2, 3, 4. How many real zeros do we have? Technically, we have how many real zeros? We have 2. Which means if there's 2 real, that means there's going to be 2 imaginary zeros. Okay? So if there's 2 real zeros, there would be 2 imaginary zeros. All right? A total of 4 zeros. 2 real and 2 imaginary. Now, what do you guys think about the leading coefficient? Is the leading coefficient going to be positive or negative with this graph? The whole graph screams negativity. Because it's going down and down. Okay? So this is going down towards negative infinity, this is going down towards negative infinity. So if I broke this down into what's called the left in behavior and the right in behavior, the limit of this function is going to equal negative infinity on the left side, and the limit of this function is going to equal negative infinity on the right side. Whether x is approaching negative infinity over here, or whether x is approaching positive infinity on the right side. So as x is going to the right, it's going to negative infinity. As x is going to negative infinity towards the left, it's also going to negative infinity.
What was the last one you
Go back. The right in behavior, as x is going to the right, this is going down. That's why it's negative.
used? If any point goes down, it's negative.
If you see the in behavior over here, it's going to be negative. Okay, if it's going down, if the in behavior on the right-hand side is going down, that means it's going to negative infinity. If the in behavior on the left is going up, that means it's going to positive infinity. All right? So there is all of your answers. What I want you guys to do is I want you guys to do 3 and 4 on your own. 3 and 4. Okay? You're like, what is 3 and 4? These are 3 and 4. Okay? See how similar they are to the last two that we just did? Okay? So I want you guys to go ahead and do those on your own.